Welcome everyone to episode 40 of Games with Go. Today is going to be our second OpenGL episode, and we're going to make some OpenGL helper functions, so OpenGL will be more pleasant to work with. And we're also going to fix a couple problems from last time. So one of the problems that a viewer pointed out to me is we're making our stuff here all in OpenGL 3.3. And we grabbed the 3.3 core version of the OpenGL bindings for that reason. And we picked that because OpenGL 3.3 looks pretty much the same as the most recent version, but is compatible on far more hardware. And so someone was trying to do the lesson and it wasn't working. He had an older computer that didn't support anything much higher than 3.3. So it turns out that if you don't tell SDL specifically, then when you create the OpenGL window, it does it in the latest version, which is probably what we were seeing when we printed out the version. We were seeing 4.6. So it wasn't working for him, and so what we have to do is set the particular version of OpenGL before we create the window. And so we can do that with some SDL functions. First one is GL set attribute. And we're going to set the, context profile mask. And we're going to set it to profile core. So that's telling it to use the core profile, not the compatibility profile, which also has old deprecated functions. That's just matching this core part here. And we set another attribute. We set the major version, and that will be 3. And then we set the minor version. Also for 3.3. So now if we run it, we get back the version 3.3. Okay, so that should help people out if anyone had trouble running this last time on an older computer or an old 3D card. That should help. Okay, the other problem we had yesterday was with our fragments, our shaders. We were having the problem where there was some overwriting of memory when we were getting the strings. They would only compile in a certain order. So what was going on is, remember that OpenGL is a C API. And so the strings that it's using behind the scenes are C strings. And the language C doesn't really have strings. People just make arrays of bytes. And the convention that people usually use to treat them as strings is to indicate that the string is over with a null character, a byte that is the value 0, which is different than the character 0. And that's because in C, arrays don't have a size associated with them. An array is just a pointer to a location in memory with a type on it, and that's it. So you either have to pass along the size of your array with your array all the time, or use some convention like a null terminator, so that when OpenGL is reading the string, it hits the value 0 and can stop. So to fix that problem, you just have to append one more character, the null character. And this is an escape sequence that means put the byte 0 right there. So that just appends it to our string. So that fixes that problem we had last time. I assumed wrongly that this GL stirs function would handle that for us, but it doesn't. Okay, so what we're going to do is we're going to go through all of our OpenGL calls, and anytime we have one that's a bit weird from a Go language perspective, or anytime we're repeating ourselves, like we are doing all this repeated stuff to load shaders, we'll make helper functions instead. So what we're going to do is we're actually going to make a whole new project. So let's go to File, Open Folder, and go to our root Go language, our Go source directory. and we'll make a new folder, and we'll call it, I'm going to call it GoGL. And this is where we're going to make our Go OpenGL helper functions. And by making it a separate package, we'll then be able to use it in any future projects we do. We can just include this package, and we'll have those functions available. Okay, so let's call it gogl.go and package GoGL. So this is not going to be an executable program, so it's not going to be a package main. It's just going to be a library that we can import in our other programs. Okay, so let's do this. Let's can we split screen this? Let me do it like this. I'm going to back out to the big folder, so we can have our hello triangle open and our GoGL open at the same time. Then I'm going to Alt View. How do we split screen? Split screen. There we go. I'm going to put hello triangle on the right. Okay, so version's a good one to start with. It's very simple, probably not worth doing, but it'll be good practice. So we can make a just a get version function that returns a string. And then we can rip that out. Oh, we'll need to import the same OpenGL stuff here. So import OpenGL. Okay, and then here we'll import github.com. Use your own name here. GoGL. Okay, it found it. So here we can just say GoGL get version. Okay, so that's just an example of taking something that's a little bit non-idiomatic Go, making a wrapper function that makes it idiomatic. All right, so now let's do one for shaders. That will be a little bit more useful. So we got all this stuff we're doing for shaders, all right? And some of it's tricky, like you can mess up this null termination. So we're gonna have a function. Just call it make shader, and it'll take in a shader source string, and then maybe a shader type, and the shader types are just ints. It looks like uint32. Okay, so all right, so then we're just gonna take, and I'm gonna delete this debugging print line we had. Take all this, copy pasta into make shader, and then we'll just tweak it from there to make it general, so we can use it for any shader. So this won't be a fragment shader, it's just going to be a shader. And this, the type will not always be a fragment shader. We're going to pass in shader type. And then we're going to take care of our null termination problem by appending the null terminator in here, so that the person using this function won't have to worry about it. Right, and if they've already put an null terminator, that's going to be fine. It'll just take up a little bit more memory. It won't hurt anything. Okay. I'm going to call this shader ID. That's really what it is. It's a it's a uint32 that represents the shader. It's like a key for it. That's the shader ID. Free, remember, frees the memory used by this C string. Compile shader ID. This is all good. Strings. Okay, so we need to import strings here. Okay, so this won't always be a fragment shader, so we don't want to say failed to compile, failed to compile fragment shader. We're just going to say failed to compile shader. It's usually pretty obvious which shader it is by the code itself. So, okay, so then we can return shader ID, which is a uint32. Okay, so now we have this function. So then all of this can go away. And we can just call make shader with the fragment shader source and GL. What was it? Yeah, fragment shader. Go to GL. All right, so that saves us a ton of lines of code. And we can reuse it for the Vertex shader as well. This just becomes gogl.make shader. Vertex shader source, gl.vertex shader. All right. If there's any questions so far, let me know. And we can remove the null termination because that's taken care of for us by the helper functions now. So let's make sure this still works. Hello triangle. Good to go. Still works. Okay. So an additional thing we can do, because it's easy to do in Go, is you'll notice that a lot of these IDs we get from various things like the vertex array objects and shaders and programs. They're just uint32s, which means a function like this, attach shader, which takes a program and a shader. You can easily swap these on accident. Right? You can have millions of lines of code and make that mistake once, and it'll compile fine. We can run go build hello triangle.go. Compiles fine, no errors. Because those are both uint32s, so the compiler has no reason to believe it's wrong. But if we run it, why did that work? What if we do it with both? I wonder if OpenGL can detect this. Okay, no. So that was enough to break it. It might not have mattered because our Vertex shader doesn't do anything. I'm not sure. That was interesting. But you can have a program that crashes. Sometimes you just get a black screen and you just look at the black screen and you have no idea what's wrong. And you have to either use a third-party OpenGL debugging tool, or you have to call, there's a function getError. It can tell you if an error has happened. So you have to like put that after each call if you want to know where things went wrong. And that can be hard if you have a lot of code and you aren't sure where to put your getError calls. Okay, let's put everything back the right way. So Go has type aliases, like many languages do. So you can do something like this. You can say, let's make a new type called shader ID, and it'll be a uint32. So that's called a type alias because it just means you're making a new name for a type, but it's really just some other type behind the scenes. In most languages, when you do this, they are not strict or distinct type aliases. It means that if you had two different things defined, and you could set a shader ID equal to a program ID, and it would be fine. In Go, they are distinct, so you cannot set a programmer ID to a shader ID because they're different types. The compiler will complain. So it's really easy in Go to make new types for these OpenGL IDs, so you can't ever mix them up on accident. And it can also make the code clearer. So it's not a big deal, but because it's so easy in Go to do this, I like to do it. So we'll make a shader ID, a program ID. We also have Vertex array objects we could do, and Vertex buffer objects. So we could do video ID, video ID. What's another one? That might be it for now. We may run into more. We just make them as we need them. So then we can make this return a shader ID instead of a uint32. And so we have to cast this to a shader ID. Right, so all the casting and possible sources of mistakes will be taken care of in our helper package, so that then when you go to make a game or something, you can't make the mistakes, assuming your library is good. Okay, but that's probably going to introduce now a bug here, because now we don't have uint32s anymore. But we're going to make helper functions for all this stuff too. So to create a program, we're doing all of this stuff. So let's make a helper function to create a program. You know what? Let's call make shader create shader, because it's a little more consistent with SDL and OpenGL. We'll make this create program, and it will take in a vertex shader and a fragment shader, and it will make the program ID. So we'll just take in a vert and frag. You can tell I've been doing some C programming. And then we will attach, basically just do this. So we'll attach our vert, attach our frag, link it. Also want to do the error reporting. Link status, success, log length. Get program. Okay, and then this, remember, deletes our shaders, because once it's compiled, we don't need those resources being taken up anymore. This will be actually, so here we'll cast these back to uint32s. Oh. C programming again. And same thing here. Then return program ID shader program. All right, and now all of this can go away. And we just create a program. Okay, pretty soon we won't have any code at all. It's kind of a goal. Okay, next up is the vertex buffer array and a vertex buffer object and vertex array object. So we're going to think about how to make helper functions for this. So the first thing that's a little bit weird is having to declare your variable uninitialized, pass a pointer to it to fill in, and bind it. So we tend to do the generation and binding all at once, and we tend to just pass it, tend to just do one at a time. At least we are for now. So we can make a helper function to do that. We can make a gen bind buffer. And then want to tell it, want to pass in the target, because that could differ. And then we're going to return, we have VBO IDs, right? Yep. VBoid, kind of like that. All right, so we're just going to do this same stuff. This will be target. And we'll cast it to a VBoid. So something you may have noticed is we do still have some things that aren't totally strongly typed here. Haskell programmers would be annoyed, but you could like make different IDs for vertex shaders and fragment shaders. We could make an enum here for target that only lets you pass in valid targets. You can go really deep with this if you want to, but sometimes it is more trouble than it's worth. Especially when like you're referring to sample code and it says, you know, just pass GL array buffer, and you don't have access to that. You have to end up going to glgo dot, you know, buffer target dot, and then like find the equivalent thing. So you got to find a balance between sort of type safety and convenience here. I don't like to go much further than we're going, but you can experiment with that at home if you want to. People have done that sort of thing in other languages. Like there's a C++ library that does it, so it's impossible to call things wrong. Sometimes it ends up with a lot more typing though. Okay, so now we could say VBO is equal to gen bind buffer glgo. And we can delete some more code. Do the exact same thing with VAOs. And these don't need a target. Oh, gen bind buffer needs target. What was the target? Array buffer. believe. OpenGL. All right, next up is buffer data. So this is a nice one to simplify because there's a lot of silly stuff we have to do. Like we're passing in the size when an array already knows its size. And we're having to do this special pointer conversion and so on. We really should just be able to say buffer data, array buffer, pass it the vertices, and pass it GL static draw. So let's make a buffer data. And because Go requires you always prefix things with the package name, we can make the names the same if we want. Let's see. I'm going to try to keep the names the same. So target. And then we're just going to have our data, which, what do they call that? Yep, data. And that'll be a slice of float 32s. And then this is called, last function is called usage. So I'll just grab that. So this will be target. We'll get the length of the data. And so because we've written this function to only take float 32s, then we can count on this always being 4. Because we're passing the total size of the array in bytes, which is the number of items times how many bytes per item. If Go had generics, we could write a function that used generics. You can do things like, say, t, which means it would be like that in C#, for instance. T could be any type, and then here you would have to write some special code to get the size of the type. Then you could pass in floats or ints, and it would work either way. But Go does not have generics, so if we wanted to do this, we would have to make another function if we wanted to support integers or float 64s or something. In fact, we should probably call this buffer data float for that reason. So we'll get the pointer to the data and then pass on usage. Okay, so this becomes the more sensible GoGL buffer data float vertices and then static draw. I have some errors, strings. We're not using that anymore here because we do it in here. So take that out of the import. And yeah, this is expected for now. Okay, next up is a trib pointer. And if you remember, that's what tells OpenGL how our data is laid out. Right? We tell it what the types are, where they are, how big they are, and so on. Do we need to change this? Does it make sense? I don't think it makes sense to make helper functions for this. I can't think of a good reason right now. It's pretty straightforward as is, so we'll just leave it. One you can do is like some people wrote to me and said they were confused by why are we calling bind vertex array 0. So binding to 0 in OpenGL means unbind. So you could do something like this. For clarity's sake. Not really important, but you could. Okay, clear color and clear are no reason to change those. Those are perfectly normal go. Use program. So now we're going to make use program take in program IDs so that you can't mess it up. You can't accidentally pass a shader, a Vertex shader ID in there, for instance, which is exactly what I've done before and been confused why my screen is black. So use program. We'll call this program ID. And same idea with bind vertex array. We're going to make one that takes. I'm going to keep it here next to the generation. And then draw arrays is simple as it is. So we'll leave it. Okay, so this is just a start of a OpenGL helper library. And as we go through and do more things, we'll add to this. We'll build it up. In fact, one thing you can do is you can make the whole shader creation one line by having one that just takes in the strings and then calls create shader for you. So this could be, for instance, string. We can call, let's call these vert string, frag string. Let's say vert equals create shader vert string. And frag create shader frag string. GL vertex shader. GL fragment shader. And then over here, that then just drops down to one line. We can get rid of. Okay, what's not happy here? Oh, VBO declared and not used. So when this happens in Go, if a function returns something, but you don't need it, does it? Okay, doesn't complain about that. So just don't use it. All right, let's see if it still works. Wonderful, still works. Now our program is much, much shorter. Okay, the next thing we're going to play with is hot loading shaders. This is a really convenient thing. It's very common when doing 3D programming of any type to want to experiment with shaders. And especially if you're learning how shaders work, you might do a lot of experimenting, right? Like we can change a color, but when we do that, we have to recompile the whole program to see what it's going to look like. And so what you can do is do that at runtime instead. So the first thing we'll need to do is be able to get shaders from a file rather than from a string. So let's do that. When we do this, there is a way to get cross-platform paths. So I'm reminding myself of how to load a file. Okay, so we want io/io util. So we can call read file on the path. We get our shader file and an error. And we'll make this return shader ID. We need the shader type as well. So this one should be, it's not a string. How do we get a string? Oh, we can just cast it. Because strings are just array of bytes after all. Then we can call create shader. All right. Let's make a subfolder under Hello Triangle called shaders and 2 new files. Do hello.vert, hello.frag. And we'll take our shaders that are inline right now and put them in files. And by the way, there are some VS Code extensions to do syntax highlighting on shaders that you can get if you want. I thought I had one, but I might not be using the right extensions that it's expecting. Okay, vert and frag. Let's make this path. No. Let's make this path. We'll call load shader from here. And then here, over in Hello Triangle, we can delete this to do because we know why that was happening. Now we can just pass the path to our thing. Oh, and here's the trick to do open or cross-platform paths. So we need, what is it, path/file path? Go has a built-in tool for cross-platform paths. What's it called? So file path.dir. Well, in this case, it doesn't matter. This is just maybe it matters. I'm not sure. I'm going to look this up later. The problem is that paths need a different slash on some operating systems than others. So we got hello.vert. And hello.frag. Let's see. All right, it still works. Then we can change it. And it changes. So the next step is we need to identify if the file is changed at runtime. So what we'll need to do is any shader that we load, we need to keep track of it. Keep track of the path so that we can reload it. The goal here is to be able to change these, and just when you hit save, see the program change. So we need a map. Let's see, what's the Golang syntax for maps? Key type, value type. So the key is going to be I don't think we do need a map. I think we just need strings. Well, let's try it. Let's go with it. Okay, so something else we should do is this should return an error. So we can print an error. Then how do we build, how do we make our own error? I think we just return a string. So if there's no error, error.nil. Put parentheses around these. so it's lowercase. Do we have to make a whole separate type? I cannot remember. So is there an error package? No. Errors.new. Okay. It's errors. There we go. Sorry about that. I want to make this sort of behave properly. So if that has an error, we get an error. So we'll get a shader ID. This can also return an error. All right, cool. So if we create a shader successfully, then loaded shaders will get our path. We'll append the path to the loaded shaders list. Then that will be the list that we want to check to see if any files have changed. So there's a format.error. Yep, that would have worked. Thanks, chat. All right, so check shaders for changes. So we'll iterate over all of our loaded shaders. So we're going to need to check to see if the file has been changed. In order to know if the file has been changed, we will need to know if the timestamp has changed. So we're going to need more than just a string here. We're going to need a struct. Call it shader info. And we'll need the path. And we'll need a timestamp. Not sure what type that is. Let's see how we get when a file was last changed. Last accessed date and time of a file, no. Modified date and time. os.stat. Then we get the mod time. Okay. By the way, this is often a very hard thing to do. To to do this reliably. It's possible Go's core library does it reliably. Most languages don't. But for debug purposes, and this is really the only time you would use this is for debug purposes, it doesn't need to be perfectly reliable. So it's not usually worth going through the trouble of making it work perfectly, because it can be impossible on some operating systems. Okay, so we're going to get the path. I'm going to panic for now. It might make sense to ignore this error, since it could be, you could try again. Okay, so then file.modtime. What was that function? Yeah, file.modtime. Probably need to import OS. Okay, that returns the time. So we need to import time. So now we can make a shader info with the path and mod time. Oh, wrong place. And loaded shaders needs to be shader info. Actually, this is going to be lowercase. I don't think anything external needs to know about this stuff, so we won't export it. Remember, capital letters on the start of a function or variable means it gets exported, so other packages can see it. Lowercase means it does not. All right, so now we're going to get mod time again. And compare it. This will be the shader info's path. I'm checking to see if there's a, yeah, it's got an equal function. So if our mod time equals the shader info's mod time, this one if not equals. Maybe we should see if it's greater than. But we shouldn't have any time traveling shader files. Okay, so if it is modified, we're going to want to reload it. But for now, let's just see if our scheme works. Baby steps. All right, where do we have errors? Multiple value. Oh. errors are propagating. Which is sort of the point. Right, now we have to deal with our errors here. Now we can choose to panic there. Okay, so that gives us a nice API where we return errors the way Go libraries usually do. And then the programs can decide if they want to give up or try to handle it somehow. All right, we still get our triangle. So now let's see if we see something in the console here if we change the shader. We don't. Oh, of course we don't. We have to call check shaders. Okay, so we got shader modified a whole bunch of times, of course, because we keep checking it. So that works. That's good. Now, how are we going to reload our shader? Is there a way to replace a shader at the same ID? Let's see. So what I'm wondering is if we need to have a whole system of tracking shader IDs, or if we can reuse the same ID. Okay, so one thing we need is actually to check whole programs, right? Because if a shader changes, we also need to pull up the Vertex shader. Like if a fragment shader changes, we also need to pull up the Vertex shader in order to compile them into a new program again. So this should become program info. And we'll have a vert path and a frag path. And we're running out of time, so this will be a good place to stop. And then we can finish this up next time. We're not far from it. I'm just going to comment this out so we have something that builds. Yes, we won't even do this here. It's going to happen when we compile a program. So we'll to do comment it out for now. Let's make sure we still work. OS. So I'm just doing a blank import, so it will compile despite us not using it, because we're going to use it again shortly. Okay. All right, that's going to be it for tonight. We've got some nice helper functions set up, and the next thing we'll be doing is finishing hot loading, which should only take about half of the time next episode. And then once we've got hot loading shaders, we'll go on and do some more interesting stuff with OpenGL. Any questions about tonight's episodes or any past episodes or the future? I'm just going to play with errors here. See if they error correctly. And that's a good one. Could not find the file. Let's make it compile badly. Failed to compile shader. Undefined variable. Great. Okay, everyone, good night, and I'll be back Tuesday, probably. And we'll finish this up. See you then.